Welcome. This is Odum Maths. Today I want us to look at inverse of a 2 by 2 matrix. Inverse of a 2 by 2 matrix. Okay. So for example, let's say we have the matrix A that is equal to A, B, C, and then D as the elements. So how do we find the inverse of this matrix? So first, what we need to do is we find the determinant of this matrix. Okay, so the determinant of A becomes A times D. We did this earlier in the previous lesson. So that is AD. So that will multiply the elements of the leading diagonal minus elements of the other diagonal. So minus BC. Okay, so this is what we need to do first. Then we interchange the positions of A and D after we negate the elements of the other diagonals, that is B and C. So our A inverse becomes 1 over the determinants, that is AD minus BC, to multiply. So we are interchanging. D will come here and then A will come here. Then we negate these, so negative B and then negative C. Then whatever value we get from this one, then we multiply with one of the determinants to get the inverse of the matrix A. So let's look at an example. Okay, so now let's look at the inverse of this matrix. So we first need the determinant. Now the determinant of this 4 times 3 becomes 12 minus 2 times 5, which is 10. So that is going to give us 2. Okay, so A inverse 1 over 2 times, so 3, so we are interchanging 3, 4, the negative 2, negative 5. Okay, so now then we multiply. 1 over 2 times 3 becomes 3 over 2. Then this is also going to give us negative 5 over 2. Then half times negative 2 becomes negative 1. Then half times 4 becomes 2. So this is the inverse of this matrix. And please, a matrix A times its inverse is equal to the identity elements. Identity elements, that is the I. A matrix multiplied by its inverse is equal to the identity. And we talk of identity elements to be, or identity matrix to be 1, 0, 0, 1. Okay, or a unit matrix. Okay, let's take another example. Now let's look at these two examples. We are to find the inverse of the following matrix. Okay, so let's start from the first one, A. So we first need the determinant of A. So the determinant of A, that is, this and this will be negative 3 times negative 2 becomes positive 6. Then minus 1 times 5, which is 5. So the determinant of A is 1. Okay, now A inverse becomes 1 over the determinant, which is 1, times, now we are interchanging the positions of the leading matrix. So that is going to be negative 2 here, negative 3, and then we negate the elements of the other diagonal. So negative 5, negative 1. Then we multiply. So this is like 1. 1 times the same thing will be 1 times any number is the number itself. So 1 times negative 2 is negative 2. 1 times negative 1 is negative 1. 1 times negative 5 is negative 5. 1 times negative 3 is negative 3. So that is the first answer for the matrix. Okay, so now let's look at the second example. That is matrix B. So before then we need the determinant of matrix B. So the determinant of B is giving us 1 times 4, which is 4, minus negative 2 times negative 3, which is positive 6, so minus 6. And this is going to be negative 2, that is 4 minus 6. Okay, now we need to find a B inverse, so which is equal to 1 over the determinant, so negative 1 over 2, because you can write 1 over negative 2. The negative be attached to the numerator. Then times, now we are interchanging the positions of the leading diagonal. So 4 is coming up and then 1 is going down. So 1 here. And then we negate these elements. So this is already negative. So when you negate, we'll get positive. So 2 and then 3. Then we multiply. So negative half times 4 becomes negative 2. Negative half times 3 becomes negative 3 over 2. Negative half times 2 becomes negative 1. The negative half times 1 becomes negative 1 over 2. Okay. Okay, now let's look at one more example. So verify whether the following matrices have inverse. Okay, so we are going to look whether these matrices have inverse. Now, for a matrix to get an inverse, the determinant should not be equal to 0. So if the determinant of this is equal to 0, then that matrix or this matrix is not having inverse. So let's see. So now let's find the determinant of this matrix Q. So the determinant of Q, this is going to give us 2 times 3 is 6, minus 6 times 1, which is 6. So this is going to give me 0. Then, so therefore, Q has no inverse. Has no inverse because the determinant is equal to 0. Because the determinant is equal to 0. Okay, so let's try this one to see whether this has or has not inverse or has no inverse. Okay, the second one, P is equal to 5, 2, and then 3, 1. Okay, now let's find the determinant of P. So 5 times 1 is 5, minus 2 times 3 is 6. So this is negative 1. So it means P has an inverse. So P has an inverse. Okay, so let's continue to find the inverse of P. Okay, so now we are going to find the inverse of P. So P inverse is equal to we first need the determinant, and we found the determinant to be negative 1. So let's see. 5 times 1 is 1, is 5, minus 3 times 2, which is 6. So that is going to give us negative 1. So negative 1 over 1, or yes, times, then we multiply, or we interchange the positions of the leading diagonal. So this is 1, and this is 5. Then we negate the elements of the other diagonal. So negative 3, negative 2. Now let's multiply. So this is going to be negative 1. So negative 1 times 1 becomes negative 1. Negative 1 times negative 2 becomes 2. And the negative 1 times negative 3 becomes 3. The negative 1 times 5 is also negative 5. Okay, now I want us to continue to check whether, I said earlier, matrix A times its inverse should give us the unit matrix or the identity matrix. So now let's see whether this will help us, or we can multiply the matrix P and its inverse to get the unit matrix. And before then, we know unit matrix to be equal to 1, 0, 0, 1. Okay, so let's proceed to see whether this is true. Okay. Okay, now we are trying to see whether P times P inverse will give us I. And I is equal to 1, 0, 0, 1. Okay, so with the matrix P is giving us 5, 2, 3, 1. And then P inverse is also P inverse is negative 1, 2, 3, negative 5. Okay, so we want to multiply the two to see whether we are going to get the I. Now, P times P inverse. Okay, so let's see. The first matrix P is 5, 2, 3, 1. Multiplied by the its inverse. So negative 1, 2, 3, negative 5. Okay. So we are multiplying this to see whether that is going to give us the I there. Okay. Now, we said the first row of the first matrix should multiply the first column of the second matrix in that order. Okay. Now, 5 times negative 1 is going to give us negative 5 plus 2 times 3, so 6. Then 5 times 2, 10 plus 2 times negative 5. So negative 5 is going to give us 2 times negative 5 is going to be negative, so plus negative 10, which will be 10 minus 10. Then 3 times negative 1 is negative 3 plus 1 times 3. So that is 3, so plus 3. Then 3 times 2, which is 6, plus 1 times negative 5. That is going to give us negative 5. Okay. So now let's see. Negative 5 plus 6 is going to give us 1. 10 minus 10 is 0. Negative 3 plus 3 is 0. And then 6 minus 5 is 1. So then it means that when you multiply a matrix and its inverse, you are going to get the unit matrix. That is the identity or unit matrix. Okay, so we'll meet in the next lesson. Thanks for watching, and please don't forget to subscribe, share and like. Give it to your friends, tell them to subscribe so that the moment I put any video there, they will get to be notified. Thanks for watching once again. Bye.